Hi everyone, in this lecture I'm going to talk about chapter 9 inheritance in Java. So the goal of this chapter is to first learn about inheritance and understand how to inherit, override superclass methods, and then to be able to invoke superclass constructors. We also learn about protected and package access control, and we'll understand the common superclass object and to override it to a string and equals method for different subclasses of object. Basically, inheritance means to extend classes by adding methods and fields to it. For example, if you have a class already defined named bank account, and then you want to extend that bank account by adding some new methods and fields, you can write it this way. You can write class, for example, a specific type of bank account like savings account extends bank account, and then inside braces you can put the new methods and instant fields that are specific to savings account, because savings account automatically inherits all methods and instant fields of the bank account. It's superclass, but you can also add new methods and fields that are specific to this kind of account, which is savings account. Besides, you can use the methods that you can previously use for a bank account, like deposit. For example, if college fund is a savings account, you can first create an object of a savings account and then set it equal to college funds. And then after that, you can simply call the deposit method that exists for bank account. And since college fund, which is a savings account, uh, inherits all methods of bank account, it is okay to use deposit with the savings account object. In the previous example, the bank account, which is the superclass, is called the extended class, while the subclass, which was the savings account, is called the extending class. So remember this terminology. And also keep inheriting from a class is different from implementing its interface, because subclass inherits behavior and state. Also, one advantage of inheritance is code reuse. In this lecture, we use a specific type of datagram that shows the inheritance relationship between classes. As you see here, we have three classes here: savings account, which is a subclass of bank account. And since savings account is a subclass of banking account, we have an arrow from savings account from the subclass to the superclass, from the extending class class. And then you need to know that every class in Java extends the object class either directly or indirectly. For example, here, bank account extends object class by default. So let's take a closer look to the example that we just saw. In class savings account, which extends bank account, we need to specify the added instance fields and methods that are not in the bank account and are not inherited from bank account. For example, the savings account needs its own constructor. So here we write constructor for savings account, which gets rate as an input. Rate is a double, and it basically specifies the interest rate of the savings account. You know that not all accounts have interest rate. That's why interest rate which is specific to savings account has to be defined here inside savings account. And then we have another method called add interest. This method simply calculates interest first by multiplying interest to get balance and dividing by 100, and finally it deposits that amount, that interest amount. Obviously deposit is a method that is defined into the in the superclass, which is the bank account. It is not defined in the savings account, but still we can call this method. And lastly, we have another instance field in savings account class, which is called interest rate. Obviously, interest rate is not inherited from the superclass because not all bank accounts have interest rate. And then you need to note that in this example, when we were going to obtain the balance of an account in the savings account, we call get balance. And whenever we wanted to uh, change the balance, we use deposit. So the add interest method in savings account has no access to the private fields of its superclass like balance. Instead, it can call the get balance method so that it can read those variables, like in this example, balance, and write on them by calling another method. In this example, it was the deposit method. So this feature that you cannot have access to the private fields of your superclass is called encapsulation. Also, note that the add interest method called get balance without specifying any implicit parameter. So it just calls it in a way that it is defined inside the class. In fact, it's not defined inside the class, it is defined in its superclass. But still, you can call it without specifying an implicit parameter. So if we look at the layout of a subclass object, you can see that it has two parts. It stores all the instance fields of its superclass. In this case, for example, balance, which belongs to the superclass bank account, and also it has another portion which stores its own instant fields, the instant fields of the savings account that is not inherited uh, from the superclass. So we have balance, which belongs to the superclass. We have interest rate, which belongs to the savings account itself. We can have a hierarchy of inherited classes. For example, consider J component in Java. This class has methods get width and get height, but it has a layer of subclasses: JPanel, JText component, JLabel, and abstract button. And even the subclasses like abstract button have their own subclasses. So, for example, the abstract button class, which has methods to get and set button text and icon, has two subclasses, J toggle button and J button. These are the two specific kinds of buttons, two specific kinds of abstract buttons. And then another inheritance level exists with J toggle button. J toggle button has two subclasses, J checkbox and J radio button. So as you see, when you construct the diagram for all the inheritances in different layers, we'll create a tree in which the J component is at the root of the tree, and we have different layers of inheritance in this tree. So, in the example of bank accounts, consider that a bank can offer uh, the following two types of accounts. One is a checking account, and the other is savings account. The checking account has no interest, and you can do small number of free transactions per month, but additional transactions are charged a small fee. For savings account, uh, we need to have some mechanism to earn interest that compounds monthly. But in order to implement these functionalities in Java, uh, we know that all banks should support all bank accounts should support the get balance method and the deposit method and the withdraw method. So we put all of these functionalities in the bank account. But the deposit and withdraw method for different bank account types uh, should be implemented differently. Also, checking account needs a method called deduct fees, and savings account needs a method called add interest. So both the savings account and checking account, they both extend bank accounts, so they are both subclasses of the bank account, but each one of them need to define a different method. As I said, checking needs to define deduct fees, savings need to define uh, add interest. Also, the difference between implementation of deposit and withdrawal should be specified in the body of classes, checking account, if needed. For the checking account in the previous example, obviously we need a counter that counts the number of withdrawals and deposits so that we know that how many or which transactions are free and which ones are not, and we deduct fees for the ones that are not free. So the counter that counts the number of withdrawals and deposit in checking account is a new instant field that does not exist in the bank account, and it's not inherited by the superclass of checking account. When a class inherits a method from its superclass, it can supply a different implementation of the method that exists in the superclass. We say that the subclass overrides the method of the superclass. Uh, when a class overrides a method, have the same signature, which means that you have to keep the name uh, the same as the superclass, and you have to keep the same parameter types as are defined in the superclass method. If method is applied to an object of the subclass type, the overriding method is executed. But if the method is applied to an object of the superclass type, obviously we are not going to execute the overriding. We will use the original implementation of the method. The second type of inheriting a method is to just keep the implementation of the superclass as it is and reuse it in the subclass. So basically, if you want to inherit a method, you don't need to supply a new implementation of the method that exists in the superclass. Basically, the superclass method can be applied to the subclass objects if you don't override that method. And then the third type of inheriting methods in Java is to add a method. You supply a new method that does not exist in the superclass. So new methods can be applied only to the subclass objects because the superclass uh, doesn't have those methods. How about inheriting instance fields? Can we override fields? The answer is no, it's not possible. However, you can inherit a field. All fields from the superclass are automatically inherited. Moreover, you can add a field. You can supply a new field that doesn't exist in the superclass. But the question that may raise is that what if you define a new field with the same exact name as a superclass field? In this case, each object would have two instance fields of the same name, one for their superclass, one for themselves. And then the fields can hold different value, obviously, because uh, we have two different memory cells. uh, each one stores the value of stores the value of the field belonging to the superclass, and one stores the value the subclass. So it is legal, but it's extremely undesirable because it creates confusion. In the example of bank accounts, as you remember, we said we need to provide a different implementation for deposit and withdraw in checking account because we are going to keep track of the number of transactions so that we can charge the customer if he or she wants to have more than a limited number of transactions per month. So basically, we need to override the deposit and withdraw method of the superclass to increment the transaction count. So in the class checking account, which extends bank account, we need to provide a new implementation of the deposit and withdraw method, which means that we need to override these two methods. Also, we need to have a new method for deduct fees, and also new instance fields. Uh, we know that each checking account object should have two instance fields. One is the balance that is inherited from bank account. Another is transaction count, which, as I said, keeps track of the number of transactions per month. So that is a new field to checking account. Other bank accounts don't need that. So in the example of bank accounts, you can apply these four methods to checking account objects. You can apply the get balance method. Why? Because it's inherited from bank account. You can apply deposit method, which which is defined in the bank account, but it is re-implemented in the checking account. So a deposit overrides bank account method. Therefore, you can use it. You can apply withdraw method to a checking account object because again, it overrides the bank account method. And also you can apply the deduct fees to a checking account object because it is a new method defined in checking account. So call this method too. So let's take a closer look at the deposit method of checking account. In that method, we need to first increment the transaction count by 1 and then add the amount that you're going to deposit to the balance. Okay. In order to add amount to balance, we can't just add amount to the instance field balance, because the balance instance field is defined in the superclass, and the balance is a private field of the superclass. Because of the encapsulation, the subclass has no access to private fields of its superclass. So the subclass must use the public interface that its superclass has provided. In order to solve this issue, we can simply invoke a superclass method. In this case, we can invoke the bank account's deposit method, but you cannot just call deposit method in deposit method of checking account. So you cannot call the same method name inside the definition, inside the body method. That would be considered as a recursion. We'll talk about recursions later. So instead, you need to explicitly say that you are calling the or you're invoking the method of the superclass. That's why we use the word super. It's a keyword. We write super dot deposit and the amount. So this way, the Java compiler would know which method to invoke. So it doesn't invoke the deposit method of the subclass, which overrides the superclass's deposit method. And instead, it calls the original implementation of deposit method that is defined in the superclass. So this is how you invoke a superclass method, by using the keyword super before deposit. We have another keyword, this. If you write this dot deposit, it will call the deposit method of the checking account. So this is not what we want. This would create a infinite recursion. But instead, we want to call the deposit method of the superclass. That's why we write super dot deposit, and inside the deposit method, we write the explicit parameters, which is in this case amount. So this is how we define deposit method in uh, checking account, or in other words, this is how we override the deposit method of bank account in checking account class. We first increment the transaction count in the first line, and in the second line we call the deposit method of the superclass, because the implementation that we need for the checking account class is exactly the same as the super class. However, it needs to keep track of the transaction count. Therefore, we need only two lines. In the first line, we increment transaction count. In the second line, we call the superclass's deposit method. In the same way that we override the deposit method, you can override other methods like withdraw. In this example, in this slide, as you see, the withdraw method is overridden in the similar way. Um, we first increment the transaction count, and then we call the withdraw of the superclass with the same explicit parameter as the one that is given uh, at the explicit parameter of withdraw method in checking accounts class. Also, here is a method that we define in the checking account, and it doesn't exist in the superclass. So deduct fees has to be implemented for the first time because it's a new method inside the checking account class. So here is the body of this method. We say if transaction count is greater than free transactions, it means that we need to deduct some fees from the customer because the customer is using more than the limit of free transactions. Therefore, you have to first calculate how much fee you are going to deduct from the customer by this mathematical formula, whatever that is. And then after that, you can simply call the withdraw method of the superclass, and inside the explicit parameters you simply pass the fees, which is the result of your previous calculations. At the end of deduct fees method implementation, we need to reset the transaction count to 0. Also, you see that we have some new instance fields for the class uh, checking account. We have a final, which means a constant integer that is defined private, called free transactions, which shows how many transactions are free in a month. In this example, that final variable equal to 3. And then we have another constant which specifies the transaction fee. In this case, it is $2. A common mistake that beginners make when dealing with in Java is that uh, they solve the problem of accessing the uh, superclasses private fields by creating one inside the subclass. For example, they want to uh, in, have access to balance field of the account uh, in their checking account implementation. But since balance in bank account is private, they create their own balance. And then they increment the balance by the amount in the deposit method. This is obviously wrong because this balance that you define inside the checking account class is stored in a different place than the balance of your superclass, which is the bank account. So you would have two different methods, two different instance fields with the same name that are stored in different uh, places in memory. And uh, when you are changing the balance here in the checking account, that change will not be reflected in the superclass. So everything would be wrong after this point, because if you want to make a deposit, or if you want to make, it doesn't change the balance of the superclass. It changes the balance of a new instance field that you created in the subclass, and you called it the same as the superclass's balance. This mistake is called shadowing instance fields. So we have two different balances. This is the balance. The first one is the balance of the uh, superclass bank account, and this one is the balance that you define inside the body of checking account class. So when you are depositing, when you are calling the deposit method, it doesn't update the correct balance. It updates the balance that you have inside your checking account. However, you expect that it changes the bank account, which is not the case. That's why shadowing instance fields cause errors. As we know, every class needs a constructor in Java. So if you assume that we have a checking account that extends a bank account, obviously checking account needs to have a constructor. So inside the constructor of a checking account, we have to first construct the superclass. So this is how we invoke the constructor of the superclass. We write the word super, and in parentheses, we write the explicit parameter that we need to pass to the constructor of the superclass. After we are done with constructing, we can simply initialize the instance fields that are new in the subclass, and they are not inside the superclass. Therefore, by calling the superclasses constructor, they are not initialized. So in this case, transaction count was the field that we added to checking account, and it wasn't in all the bank accounts. Therefore, after calling super initial balance, we need to call transaction count is equal to zero. We need to write transaction count is equal to zero. This is how we initialize the transaction count inside the constructor of the checking account. A very important point here is that the call of superclass constructor must be the first statement in the subclass constructor. So in the first line, before anything else, you need to call the the superclasses constructor by using the word super. Now, here is the question. What happens if the subclass constructor doesn't call the superclass constructor in the first line of its constructor method? In this case, the default superclass constructor is invoked automatically by the compiler. So what is default constructor? The constructor with no parameters, with no explicit parameters, is called the default constructor. If all the constructors of the superclass parameters, and we don't define any constructor with no parameters in the superclass, then the compiler reports an error because the compiler fails to construct the superclass before constructing the subclass. Another important point about classes in Java is that it is okay to convert a subclass reference to a superclass reference. For example, let's assume that you have a variable of type savings account called college fund, and you instantiate an object of savings constructor of savings account, and after instantiating an object, you set it equal to college fund. So college fund is a variable of type savings account which refer to an object of savings account. Also, let's assume that you create another bank account this time. The name of this time you set college fund equal to an account. So an account would be equal to a college fund. So now this time an account refers to the same savings account that you. So as you see, an account has the type bank account, but since bank account is a superclass of savings account, it can refer to an object of savings account. So a variable of type superclass can refer to an object of it's okay in Java. There is no compile error and it works without any error. Also, as we said, object is a class in Java which is the superclass of all other classes. So again, if you create a variable like an object with type object, it can refer to this to a savings account like college fund, because object is also indirectly a superclass of savings account. Therefore, you can have a variable of type object that refers to college fund, which is a saving account object. So the three object references are stored in college fund, an account, and an object. They all refer to the same object of type savings account. This is fine because object and account are two classes that are considered to be the superclass of savings account. Here is the figure that can show how the previous slide codes work. As you see, all three variables with three types object, account, and savings account, they all refer to the same object with type savings account. But you gotta be careful when you refer to an object of a class with the type of its superclass. The superclass references don't know the full story. For example, if you have the reference an account that refers to a savings account, and you call a deposit method, that's fine because both the account and savings account have the method deposit. But if you call the method add interest for the object in account, the compiler doesn't let you do that because the compiler sees that an account has type account, and a bank account does not have an add interest method. Although we know that an account refers to a savings account, a savings account has a method, but bank account and bank account doesn't have add interest method. uh, Writing this line is not acceptable for the compiler. Uh, so when you convert between a subclass object to its superclass type, the value of the reference stays the same, which the value, it's the memory location of the object, but less information is known about the object. So the question here is, why would anyone want to know less about an object? So in other words, why should we have a superclass reference to a subclass? To answer this question, you can take a look at this example of transfer method, which basically transfers some amount specified in the first parameter to the other bank account specified by other variable. So basically in this method, we have to first withdraw the amount from the current bank account, and then after that we have to deposit the same amount to the other bank account specified in the second explicit parameter. So this way that the way that we write this method, we assume that other has type bank account, and bank account is a general type which is a superclass of both checking account and saving account, for example. So this method, the method transfer, works for both for all types of bank account. But if he was writing it using a specific type, for example, if other had type savings account, then you couldn't call transfer for a checking account, right? because the superclass of checking account. Saving account are subclasses of bank account. Therefore, when you set the type of other as bank account, you can call transfer for any type of bank account. One of the helpful features of Java programming is that you can convert from a superclass reference to a subclass reference. To do this, for example, if you want to convert an object to a bank account, you can use explicit casting. So, for example, an object is a variable of type object, but you want to cast it into a bank account and set it equal to an bank account an account. So you write bank account an account, which is a variable of type bank account, equal to an object that is casted into a bank account type. So you write in parentheses bank account, and then you write an object, which means that you're converting the object to a bank account, and then after you convert it, you can set an account equal to it. It's dangerous because if you are wrong and the object that you are casting into a bank account doesn't actually refer to a bank account, you will see an exception. An exception is thrown. The solution to make sure that you're wrong and the object doesn't refer to a bank account is to use the instance of operator. Instance of operator tests whether an object belongs to a particular type or not. For example, in this scenario that we cast an object to a bank account, we can say if an object is an instance of a bank account, then do the assignment, which means bank account and account is equal to an object that is casted into a bank account type. An important point in Java is that uh, the type of a variable, the static type of a variable, doesn't completely determine type of object to which it refers. For example, if you have a variable of type bank account, like a bank account in this example in this slide, and you set it equal to a new savings account, then the bank account holds a reference to that account, and obviously savings account is a subclass of bank account. So the bank account itself has a static type of bank account, but it dynamically refers to a savings account. Method calls are determined by the type of actual object, not the type of object reference. So, for example, if you have an account with type bank account and you set it equal to a new checking account, and then you call the deposit method on the account, then the deposit method will call the or will execute the implementation of deposit method in checking account. Why? Because an account, although has a type of bank account, but it holds or it refers to a checking account object. However, compiler needs to check that only legal methods are invoked. Uh, Therefore, compiler always cares about the static method, static type of a variable. So if the static type of a variable is object and deposit on the object, compiler says the object class has no method called deposit, and it doesn't accept it, and you will have a compiler error. Why? Because compiler has no idea whether the object, whether an object in this example refers to a bank account or refers to any other class. That's why uh, compiler doesn't accept this. The compiler says, okay, an object has a static type of object. An object class doesn't have the method deposit. Therefore, it's not acceptable to write an object that deposit. So keep in mind that compilers care about the static type of a variable, but when you call the methods, the method call are dynamically determined by Java, which means that in the previous example, an account which had type bank account but referred to a checking account, and when you call the deposit method on an account, the deposit method will be called from checking account, not the bank account. In this slide, we're going to define polymorphism, and we're going to see how polymorphism works in Java. Basically, polymorphism is the ability to refer to objects of multiple types with varying behavior. In Java, you can write a method like transfer, as you see in this slide, which has two parameters, amount and other. The type of other is a bank account. But since bank account is the superclass of both checking account and saving account, and maybe any other type of bank accounts, you can call transfer for any type of accounts, and you don't need to write different methods for different types of bank accounts. For example, if other in this example refers to a checking account, then the method deposit in the last line of this method call will call the implementation of deposit method in checking account class. However, if other refers to a savings account, then the deposit implementation of the saving account class will be executed in the last line of this method. So depending on type of amount and other, different versions of withdraw and deposit are called. You know that in Java we can define methods and fields in a class, and also we'll see later that you can also define one class inside another class. So when you define methods, fields, or classes in a class, you can specify the access control. The access control can be either public. If it's public access, it means that that method or field can be accessed by methods of all classes. If it is private, the private access means that it can be accessed only by the methods of their own class. And if it is protected, it means that it can be accessed by the methods of their own class and the subclasses. The last type of access is the package access, which is default access, which means that if you specify no access modifier before defining a method or a field or a class, then that method or field or class would have the package access. The package access means it can be accessed by all classes in the same package. So remember that when you mention an access modifier, it's either public, private, or protected. If you don't mention it, it would be a package access. So here are some recommendations for specifying the access controls. For instance, in static fields, always use private, but there are some exceptions. For example, if you have a constant variable, which is a public static final, it can be a constant because it's useful and it is safe because no one can change it. Also, some objects such that system.out that we use for printing something on a screen need to be accessible to all programs, so it is public. And occasionally some classes can be uh, accessed as public. We'll talk about them later when we talk about inner classes. And then uh, the methods are either public or private depending on functionality of that method. And then classes and interfaces that we will talk about them later can be either public or package access. Um, so a better alternative to package access in classes is to use inner classes. Again, we're going to talk about inner classes later. Inner classes should not be public in most cases. And then the very important point here is that you got to be aware of accidental package access, because sometimes you forget to put the access modifier public or private, and then when you forget writing that, it becomes a package access. And then when it is package access, all the methods in all the classes in the same package can have access to it. It's important to keep in mind that any class that you define in Java, use the word extends, um, it automatically extends the object class. So object is the cosmic superclass for all other classes. The most useful methods of object that other classes would have it because of inheritance is there are three useful methods. One of them is toString, which has no input parameter and it returns a string. The second one is equals, which has one input parameter of type object and it returns a boolean. And clone, which returns an object, and it basically clones an object and return the copy of that object. So since all classes inherit these three methods because they are subclasses of object class, it's a good idea to override these methods in your classes if you want to customize the functionality of these classes. Let's look at an example of how to override a method in object. Let's assume that you want to override the toString method. As we said before, toString representation of the object. It is very useful for debugging. For example, if you have a class like rectangle, obviously it should be a subclass of object and it would have a toString method. So for example, if a rectangle is constructed by these four numbers, as for example, the first two are coordinates of one of the vertices of the rectangle, and then the third parameter, which is 20, is the width, and the last parameter, which is 30, is the height of that rectangle. You can simply over to a string method, so that when you call the toString method for a rectangle object like box, it returns a meaningful string like this one: rectangle in brackets, x is equal to 5, y is equal to 10, width is equal to 20, and height is equal to 30, so that when it prints out, the person programming can see what features the rectangle has, and it is useful for debugging purposes. I'm going to show you in the next slides how to override a toString method so that it can print out these meaningful strings. And then it's important to know that the toString method is automatically called whenever you concatenate a string with an object. For example, in this piece of code that we had, if you write box is equal to in double quotations, which becomes a constant a string, and then use the operator plus, which is used for concatenating two strings, and then use the object box, which is a rectangle, the compiler automatically calls the toString method of box, and obviously the result for this box equals java.awt.rectangle brackets the features of the rectangle close brackets. So the box equals is the string that we concatenate in the as the first and java.awt.rectangle equals the features of the rectangle is the string that toString method returns. How does it return this meaningful string? It returns it because we override the toString method of object class that rectangle inherits from its superclass. Before I show you how to override the toString method of object, let's see if you don't override it, what's going to happen. If you don't override it, then the object of toString prints the class name, followed, and after class name, you have a hash code of the object, which is a random number. So for example, if you create a bank account like mom's savings, and then call the mom savings the toString and set s as a string equal to it, then s would have the following value. S would be bank account, which is the name of the class, at sign, a random string, a random number in hexadecimal base. So as you saw, the toString method of object class doesn't provide the understandable and meaningful representation of an object. So if you want to provide a nicer representation of an object, you need to override the toString method. This is how we do it for bank account, for example. You simply write these lines of code inside the method, inside the class bank account. You write public string to string, which is the exact same signature of toString method in object class. And inside braces, you simply write return bank account balance is equal to plus the actual balance of the bank account plus close brackets. So this way, when you call toString method for a bank account, it writes the bank account and it writes the balance that bank account has. So this way, it's understandable when you call the toString method for a bank account like mom saving. This way, if a programmer wants to debug, he or she knows that what kind of bank account we have and what's the balance, and then you can also add more information in the toString method so that you can see more details about the bank account that you called it toString method. As another method of object class, let's talk about the equals method. The equals method of object class tests for equal contents of two objects. For example, if you have two objects of class coin, and assuming that class coin has two features, value and name, the equals method tests to see whether the two objects that you see here, coin 1 and coin 2, have equal content or not. The implementation of equals method in object class is not that smart, and for example, in this case, if you call the original implementation of equals in object and you don't override the equals method in coin class, then simply it returns false when you test coin 1 and coin 2, because because coin 1 refers to a different cell of memory than coin 2, or the equals object of the equals method of object class simply returns false because it says coin 1 and coin 2 have two different content. It doesn't look at the values and names, and it doesn't compare these two to see whether they're equal or not. If you want to do a smart comparison and do a smart test on equality of two objects, you have to override equals yourself and define the criteria for equality yourself. In the next slide, we'll see, in the next two slides, we'll see how we can do it. This is an example of when the equals method of object class returns true. In this case, it says, okay, coin 1 and coin 2, they both refer to the same object, so it returns true. But we want to have a smarter equals method so that even if they refer to different cells of memory, but the coins have the same value and name, the equals method returns false. So we're going to override it. A little too small. An important point about overriding a method is that you need to keep the signature of that method as it is in its superclass. You cannot change the signature of method in the subclass and say I'm overriding it. That's not true. For example, in this case, since we are going to override the equals method of object class in its subclass, which is coin class, we have to write the same signature in the first line. We have to write public boolean equals, and the type of the explicit parameter of this method should be object. So obviously we need to cast this method, this explicit parameter into a coin, because we are going to use the fields of coin class, so we cannot keep it as object and call the and then have access to the instance fields of the coin, which are name and value. So the first thing that we do in this method is to simply cast other object into a coin called other. This is the syntax that we need to follow. We use the word coin in parentheses before other object, and then you set other equal to the casted other object. And then in the second line, we simply return the following: name dot equals other dot name, and value is equal to other dot value. The two equals here is an operator that works on two integers or float or double variables. So it basically checks whether the values of two coins are equal or not. This should be true, and we should have the same name for the coins, which means that you have to call the equals method of the string class, which basically checks whether the two names are equal or not, the name of the current class and the name of the other class.